Hey, it seems like we're getting a lot of interesting models suddenly out there, and they're all getting very eeringly close to the artificial general intelligence. And the common technological factor of most of them, or all of them, is the idea of test time compute. I'm going to talk a little bit about test time compute today and what's going on behind the scene, and probably what are the implications of test time compute for us if you are building something for enterprise, for example. Is there any use in test time compute or not? So the idea of test time compute is actually very simple, relatively simple. I guess all of us have used ChatGPT. Looks like these things have the tendency of going to rabbit holes because they're generating tokens after tokens after token. What's happening is they're unable to actually reflect on what they're generating and fix it, right? If we are giving the ability of, like, when we are in doing the inference, when we are running these models, if we have the ability of reason and see what we are generating and go back and generate another answer or mix multiple answer, that would be awesome. And that's exactly what TTC is doing. I think TTC is very important, especially for companies like NVIDIA, if you're asking me, because it means that we now need a lot more hardware to run these models. We used to need a lot of hardware, GPU acceleration to actually train these things. We also now need a decent chunk of like hardware to run these things. It's a huge disruption because we used to think very linearly. So if you want a better model, build a larger, have more parameters. That seems to not be the case anymore. So there is a level of sophistication that now we added that is helping us to build very sophisticated models, not necessarily solely because they have more parameters, right? In their estimations now, more than 50% of the new models will be TTC. And we are going to talk about, we're hopefully going to see a lot more competition as well, because building these things doesn't require as much training capacity. Now, what is TTC? Like, let's be very clear. Most deep learning models, they used to have two different phases. Like, you had training phase, a large amount of data these models would see, and then what would happen is you would have a test phase or inference phase, which you would use those parametrical knowledge to provide answers. This is very like common. We used to do that for majority of machine learning models, I would say. Now the test time compute paradigm is turning this thing a little bit and saying that, okay, look, the problem is when we start doing auto-regressively, we just generate token. We are missing a lot of parametrical knowledge. Why aren't we enabling these models to generate multiple answers and select the best one, for example, or evaluate and see what's going on, right? Or maybe do some sort of reward model to see which answer is better, get more information out of them before we generate the final answer. So there's some additional steps now. So generate multiple outputs instead of one, evaluate the outputs and select out the better outputs, or whatever, mix them and give an answer. As we said, there will be a huge infrastructure impact using these models. There's a huge ROI potential as well, right? Like, now you can build smaller models with TTC that can do amazingly well. I mean, DeepSeek is one example. I think the market will be flooded by these things, right? And the resource allocation would change as well because these models are, as I said, very counterintuitive, but you are now using a lot more accelerator and GPU to actually generate the answer, not necessarily to build these models, right? Like the data center, the inference data centers now need to get a bit larger. Downside, latency. Yeah, I mean, O3 takes ages to provide you an answer because it needs to think, generate stuff, checks. And of course, the hardware requirement will change. And there's a bandwidth and memory discussion as well, which I'm going to touch upon very quickly. So you have a query, you generate multiple answers, you select one. And here in the red box, mostly people are using reinforcement learning. And the reason for that is you want that to be some sort of model that rewards get better over time when it picks the right answer. This is significant, right? Like, now we can invest on improving that as well. which is a very important. I'm just getting ahead of myself, but I'm going to talk about what's going on the market in that side. This has a lot of potential for enterprises or domain specific knowledge that you now don't need information only to build these models. You also can use these informations to train these RL mechanisms as well. Of course, there's always more than just one thing. Like, how do you generate those answers? What search strategy you have to get around it? How do you verify this? Like this RL story that we talked about. Can you do like iterative refinement, knowledge integration, whatever? And also, there's a memory management discussion that's mostly driven by what DeepSeek people, the lab in China did, right? They showed that with multi-head latent attention, they can actually save a lot of memory, valuable KV cache. But anyway, that's there is like a very long, um, uh, uh, I would say, podcast with Lex Friedman. They talk about this, but this is very interesting. The memory management is one aspect of this. Also, one thing that I guess it's related is that now OpenAI is coming with the reinforcement fine-tune idea. It says, okay, we can work with you in building that RL function better. You give us example, or you provide the examples, fine-tune that bit. I think it's very interesting. And there's a divergence between how R1 is doing it and how OpenAI did it, right? Or OpenAI is doing. OpenAI seems to be more focused on reinforcement learning from human feedback, while R1 is using mostly other like GRPO, other ways of actually doing in the piece. I'm not sure which one is better, to be honest, but I think there's a lot of potential when we include human feedback there. Also, we are making the process a lot more expensive and a lot more time consuming. Um, now, so what's going on? You can build cheaper model with more capability. You can accelerate the decision making by fine tuning those RL models specifically, or the process of selecting the best answer. You can now build these models on your own, right? Like you might want to change a little bit your strategy. I mean, people like me used to say, no way that you can run Foro on your environment, right? Or model a very large model, or that's not the case. After R1, it seems like people are changing their tune. Interestingly, because of the fact that you can now see the thinking and thought process of these models, they're actually more aligned with the regulatory requirements as well. Also, you can use the inference process. You don't need very high-end GPUs like the training. You need more acceleration, not necessarily very sophisticated acceleration devices. I mean, to a degree, not much, and that's mostly because we now know better how to manage cache, right? And the infrastructure would probably change as well, right? It's no longer only about training data centers. We need to think about inference ones as well. Yeah, thank you very much for listening to me, and hopefully I managed to communicate this piece with you.